This section talks about proportions. A proportion is an equation stating that two ratios that we'll see in fraction form are equal. If the cross products are equal, the two ratios form a proportion. If the cross products are not equal, the ratios do not form a proportion. What we mean by cross products is we're going to take two ratios, like we see in A here, and we are going to cross multiply. Cross multiplying means you're going to take the numerator of one fraction and multiply it by the denominator of the other fraction. When I take those, 1 times 9, I get 9. And then I'm going to do the opposite for the other numerator and denominator. I'm going to multiply those together. 3 times 3, which is 9. If these numbers equal each other, which they do, it forms a proportion. So we could write 1/3 equals 3/9. B, again, we have two fractions here. We have two ratios, and we want to see if they form a proportion. So we're going to cross multiply. So we have 5 times 1.2, and that equals 6. And we have 4 times 2, and that equals 8. Obviously, 6 does not equal 8. So could these two ratios form a proportion? No, they could not. At the bottom here, it's just practicing cross multiplying. I'll just do two more for you so you can see what to do. In number 1 here, I'm cross multiplying. I'm doing 2 times 12, which is 24. And I'm doing 3 times 8, which is 24. They are equal. They do form a proportion. As they're written right now, they are just two ratios. They're not a proportion yet. For it to be a proportion, you need the equal sign between them. That is a proportion. So right here, these are just two ratios, and now we're checking to see if we could write it as a proportion. And number 2 here, we're going to cross multiply. We're going to do 4 times 7, which is 28. And we're going to do 2 times 18, which is 36. They are not equal. We cannot write them as a proportion. You can try the others, and I'll write the answers down here. Okay, so cross multiplying is easy enough. Now, if a proportion contains a variable, x, y, z, so on and so forth, we still use cross multiplication. And then we're going to use our algebra skills to find the missing value. So you can see in A here, we have A over 25 equals 52 over 100. This is a proportion because I have two fractions with an equal sign between them. So I'm going to cross multiply. And again, when you cross multiply, you kind of multiply diagonal there. You do not multiply across the bottom and the top. So A times 100 is 100A. And now, since I have the proportion already made, I'm going to put an equal sign between them. And then I'm going to do 25 times 52, and I get 1,300. So notice how I kept the equal sign between them. On the first page, I was kind of writing them up and down because there was no equal sign. If you have a proportion, you want to write it like this, because now we're just solving for A. So it's a one-step algebraic equation. We're going to divide both sides by 100, and we get A equals 13. So we just solved that proportion. B, same idea here. We have a proportion, we're going to cross multiply. 12.5 times 7.5 is 93.75. Equal sign. 15 times m is 15m. I'm going to divide both sides by 15. And I get m equals 6.25. One through 7 on the bottom are the exact same. I want to show you 8. 8 is a little different because you don't just have a variable by itself. You have an expression there. You have a variable with a number and an operation. Now, because it's a proportion, we still cross multiply. That does not change. So we're still going to do 16 times 5, which is 80. And now we're doing 4 times x plus 5. I want to multiply 4 by the entire x plus 5 expression. So because I want to do that, I need my parentheses here so I know to multiply it by the entire thing. You want to show this step. You do not just want to plug in your head and write down the answer. Show that step. So now we have a little bit more work. We have to distribute first. And now we have a 2-step equation to solve. We'll subtract 20 on both sides. We'll divide by 4. And we get x equals 15. You absolutely need your parentheses. I'm going to show you what would happen if you didn't use them. If you just said, okay, 4 times x plus 5, look how much different this problem is. And then when we do 75 divided by 4, we get 18.75. As you can see, those answers are different. So because we have that expression down here, we need the parentheses because we're multiplying the whole thing. Okay, so you can try 1 through 7 now. Please pause the video, and then when you're finished, unpause it, and I will write the answers in. Okay, so where we're really going with all of this is to solve word problems. And this comes in handy in everyday life with real-world problems. If you're at the mall and you have a discount on something, or if you have a scale on a map and you want to find how far something is in real life, you can use a proportion. So how do we do this? We want to read the word problem, and then we want to set up the proportion. Once we have the proportion set up, that's the hardest part. We're just going to solve it like normal. We're going to cross multiply and solve for the variable. We really have to be careful with our units here. So please use units, and I'll show you what I mean by being careful. So the first number. Sam ran 4 miles on Saturday with his running club. How far did he run in kilometers if there are approximately 1.6 kilometers in each mile? You want to group things together. Hopefully you can see that that is a ratio right there. Remember, with proportions, we need 2 ratios joined by an equal sign. So my first ratio says there is 1.61 kilometers in each mile, or in 1 mile. That's a ratio. I could flip that if I wanted to, and I could say 1 mile over 1.61 kilometers, and that says the same thing. Anytime you have a conversion, you can write it as a ratio. So we know that there's 12 inches in a foot. I could write that as a ratio. I could say 12 inches is 1 foot. Okay, we need our equal sign. Now, when I said be careful with units, here's what I mean. Because I have kilometers in the numerator, I also need kilometers in the numerator over here. They need to be both in the numerator or both in the denominator. Same thing with miles. Because I have miles in the denominator on the left, I need miles in the denominator on the right. We're reading the problem, and I see that there's 4 miles that he ran. So 4 goes in the denominator. And the problem is asking for how far did he run in kilometers. That's our x. That's going up top. So now we have a proportion just like we had on the other page, where we're going to cross multiply, and we're going to do 4 times 1.61, and we're going to get 6.44 equals 1x. And then we just divide by 1, of course, and we get 6.44 kilometers. Units, very important. We can do one more together. A recipe calls for 12 ounces of fruit juice for every 40 ounces of soda. How much soda should you use if you use 16 ounces of fruit juice? You want to group things together again for a nice ratio. And I see that there's 12 ounces of fruit juice for every 40 ounces of soda. So that is one of my ratios. 12 ounces of fruit juice for 40 ounces of soda. Equals. Be careful with your units. I need ounces of fruit juice on the top. I need ounces of soda on the bottom. Read carefully. It's asking how much soda. So where I see soda, that is my x. And it says I use 16 ounces of fruit juice. I'm putting that in the numerator. That's the hard part, creating the proportion. I'm cross multiplying 12 times x, 40 times 16. I'm dividing by 12. I need 53.33 ounces of soda. And that's how I set up a proportion and solve.